All right, AGS1. Today we're going to talk about correlation. Now, you may have heard that word before used in the real world, but today we're going to define it pretty properly and talk about how it relates to sets of numbers. So today's essential question: what does correlation tell me about a data set? Before we get to correlation, we're going to do a quick example about how to organize this data into a dot plot. A dot plot is very, very similar to a histogram because it's kind of this visual representation of how frequent the certain data numbers are. So when I look at this, I see that there are 3 5s, 4 6s, 1, 2, 3, 4, 5, 6 7s, 4 8s, 2 9s, and a 10. So if I'm going to set up a dot plot, you literally just put the numbers underneath a line, just the individual numbers, not any of the repeats. So like this would be 5, 6, how many did I skip? 3, 7, 8, 9, and 10. So then above each of these numbers, you put how many dots there are of that number, the frequency essentially. So there were 3 5s, and then 4 6s, and 1 2 3 4 5 6 7s, 1 2 3 4 5 6, and then there were 4 8s, and 2 9s, and a 10. So now this is just, it looks a lot like a histogram, but it doesn't have bars that touch with continuous data. It's really more for discrete data. So discrete means that there's no numbers in between, the 5, there's no 5.5 or anything like that. As opposed to the histogram, where if I was to make a histogram version of this, well, not of this, but just a histogram in general, if you have like 5, 6, 7, 8, 9, 10, and then you add something, some sort of frequency on the side, and then these bars go like this. This implies that there's data in between the points. I'm just making these numbers up here. But if you have an interval from 5 to 6, that means that there could be things for like 5.9, 5.8, 5.7, things like that. But a dot plot, there's only 5s. There's no 5.5 or 5.6, anything in between there. Now we're going to do a data set that is not single numbers. It's double numbers. It's like an X and a Y. So, you guys, this is very different from all the data that we've done so far, because all the data we've done so far has been like just single numbers separated by commas. Now we have like sort of double numbers. Each one is an X and a Y. So this is an X, this is a Y, and there's lots of them. So if I wanted to, I could create sketch a graph of these points. So each of these is an X and a Y. So 1, 2 is like over 1, up 2. So that's 1, 2. Then 1, 3 is over 1, up 3. 4, 2 is over 4, up 2. 5, 5 is over 5, up 5. And then 2, 2 is right here. 2, 3 is here. And 3, 3 is here. Now, we're going to start to look at whether or not there's any sort of trend to this data. When I look at this, I see that it's kind of going uphill in general, but not really. It's like it's going uphill, but not very strongly. It's almost kind of going like a little more flat. Yeah, like if I was trying to fit a line of best fit into this, which we're going to get into lines of best fit later, it'd probably be like somewhere in the middle. But notice that a lot of those points don't fit perfectly on the line. Like it really only goes through a couple of them, like this one and this one are kind of on the line, but like this one's way far off the line, this one's off, this one's this off. Like, so correlation is basically this measure of how tightly a group of data set fits to a line. I'm going to use the word clustered. So if something has very high correlation, that means that the points are very clustered around a line. And it could be any line, like negative lines, positive lines. We'll get into that. But something that has low correlation means that it's very, it's more spread out around that line. It's not very clustered. So the thing that, the letter that we're going to be using for correlation is lowercase r. This is the correlation coefficient. Now, r has to be between -1 and +1. Like, there's no such thing as an r value of 2. It can only be +1 and -1. So, I mean, it can be anywhere in between. It can be decimals in between -1 and +1. So if you think about this whole line of correlation, things that are closer to +1 are strong positive correlation. Things that are closer to -1 are strong negative correlation. So negative would just mean that the points are going downhill, but we'll talk more about that with these pictures here in a second. The closer it is to 0, either from this side or this side, this is what we call weak correlation. And then at r equals 0, if it's perfectly on 0, this is no correlation whatsoever. So to take a look at some of these pictures here, if we look at just these first three, this graph right here has perfect positive correlation. It's perfect because if you look at these dots, they are very tightly clustered around a line. Like if you fit a line of best fit, it goes perfectly through those. They're very tightly clustered. If you go a little bit to the right here, if you look at this graph, down here, this would be r is equal to 1. The next one is an example of r is equal to 0.9. Now 0.9 is still very close to 1, so it's very high positive correlation. Positive because it's going uphill, like if you were to put a line of best fit through the data, it has an uphill trend, and it's fairly clustered. Like these are not that far off from a line of best fit. If you take those and you kind of spread them out a little bit more, so if you look at this next graph here, this is r is equal to 0.5. This is called low correlation. So the closer you are to 0, the weaker, the lower that the correlation is. So if here we have a line of best fit, it's still positive because it's going uphill, but these points are pretty far off from the line of best fit. It's like the line, you know, they're not clustered. They're very not clustered around the line. Then if you get a situation where it's kind of what I call the snowstorm, this is like something having no correlation. Like you can't really fit a line of best fit through it. Like I could do this, but then it's like, well, that's not that great because I could also do this. And that's like about the same goodness of fit. Like neither of them are that good. So this is an example of having no correlation. I also call it the snowstorm because it looks like just a bunch of snowflakes falling down. So these are all examples of positive correlation because they're all going uphill except for the no correlation. Now these are all negative correlation. See, negative, negative, negative. They're negative because all of them are going downhill. So if we look at the first one, this is an example of low correlation, but it is negative because if you look at the general trend of the line or of the dots, they're going downhill. Now, they're not very clustered. Like all the points are kind of far away from that line, so that's low negative correlation. Negative because it's going downhill, low because it's not very clustered. If you cluster those a little bit more, like on this next picture here, this is an example of R being equal to negative 0.9. It's downhill, so if I fit like a line of best fit, it's going downhill, so it's negative, and these are pretty fairly clustered around the mean or around the line of best fit. So that means it's high negative correlation. And then the last example is a perfect R equals -1. Notice that the line of best fit here is like, it goes pretty perfectly through all the points. So this is like, they're all on the line. So Pearson's correlation coefficient can go from -1 to +1. Any negative numbers means it's going downhill. So we'll put that here, negative R means, shall we say, downhill slope. Positive R means uphill slope. Now, you guys, you're going to be expected to be able to find that number. Like if we give you a data set with X's and Y's, you have to be able to punch it into something and say, oh, the R value is 0.75, and that's a fairly high positive correlation. The way we're going to do all that is with Desmos.com, and I'm going to show you guys how to work Desmos.com with a video that's embedded in the lesson, but we're also going to do it live together in class. Before we do that, though, we do want to talk very quickly about correlation versus causation. One of my favorite problems of all time, or data sets really, is a real life correlation, which this is 100% true. If you look at towns that are on, on the coast of any part in the world, the more ice cream that's sold in that town, the more shark attacks there will also be in that town. Or just in any area in general. Like the more ice cream sold means more shark attacks. So it has a fairly high positive correlation, which means as ice cream consumption increases, shark attack numbers also increase. So this is a classic correlation versus causation. There's a high correlation with these things, but not necessarily causation. So I always ask my students, like, why do you think this is? And, you can maybe think right now, what are some reasons that, like, more ice cream consumption in a town would lead to more shark attacks? Past answers that I've gotten from students are like, if there's, maybe the ice cream makes you tastier to sharks because you're full of ice cream and then they bite into you and like, yum, ice cream. No, that's not it. Other things students have said have been like, maybe that the ice cream slows you down, so you're slower in the water and you can't get away from the sharks. You guys, there's no causation between these two things. This means ice cream consumption is not causing the shark attacks. But they do have high correlation. Like I said, the higher the ice cream consumption, the more shark attacks. The reason for this is there's a third factor here. It's weather. When things get nicer outside, like when it's hot weather, people eat more ice cream in general. And also when it's hot weather, there's more people swimming in the ocean, and thus like the number of shark attacks does go up by a small percentage. So this is a classic, there's high correlation between the two, but there's not causation. Eating ice cream does not make it more likely that you're going to get attacked by a shark. It's just that the numbers go up. When ice cream consumption goes up, shark attack numbers also go up because of nice weather. All right, you guys, I'll show you how to find Pearsons on Desmos. Thanks.